Hey, Roger. Oops. Hey, Rudy. Hey, Joan.
Hi, James.
Hey, Peruse.
Hi, James.
Oh. Hey, Tony. Hey, Roger. Just give a minute for you want to join here. Let me quickly share my screen. Yeah, so from
I found this on the web.
Siri. Okay. We see many people joining now. Hey, Victor. Hey, Victor, is this your first time joining this meeting, or which company you from?
Yeah. Can you hear me now?
Yes, I can hear you.
Okay. Yeah, it's my first time. I'm independent.
Oh, okay. Yeah, if anyone, I think can just put their company name next to their name, or if they're independent, I think that would be helpful. Sometimes when new people join,
Okay.
so I think that, yeah, it's help everyone to get to know everyone from some background. So yeah, I'm just kind to quickly start, I think from what we have last time, and then we'll continue from there and see what we will cover for today. And we don't have the previous meeting. I think due to a Thanksgiving holiday in US, so we skipped that 2 weeks ago. So from the week before that, or from 4 weeks before that, right? So we were talking about discussing the ATK components, and then some other areas that we focus in at the RDL, and then the different substrate use, and then the thermal requirements and the testing requirement, all this for the assembly rules. And then I think that's probably mainly what we talked about last time as a recap here. I think as we talk about, we're going to continue this spreadsheet here. And let me share that in the screen here. I think for in the chat here for everyone that is new here, right? David, so can, or not David, sorry, Victor, that can take a look. Yeah, so we from our previous meeting, I think so there's some other area we highlighted, I think the from the component section here, we thought we have kind of the some good information. So like generally in the diagram, I think from the Intel spec that cover quite a bit. And then that's the gray area is the one that we thought it's a bit kind of futuristic, right? And right, not really, I think applicable. I think at the moment, or the prioritize, I think it can be lower compared to other components that we should be focusing on right now. So we kind of put that in the gray area, and then that's kind of the white one is we want to really discuss about, and we kind of break into from previous year, I think the RDL, the different substrates like silicon, organic, interposer, and then we have the 3D stacking kind of components here, especially for new technology related to 3Ds, the SMP rules requirement there. And then we have a different packaging kind of specific requirements, and then the thermal heating that kind in general, I think will be part of the assembly, and then and also the testing that we talk about, we want to cover that. Also, one more thing I think I missed out earlier is also some that we already covered quite a bit. I think under the Intel spec that's shared by the Chris and also the SETIS team. So I think we have quite extensive. I think again, so we're going back into the this general area. So I think one thing what I have done is based on this description that we captured, I think from previous few meetings, I'm kind of expanding that a little bit. I think what probably parameters and rule might need for each area under comment here. So I'm going to put in here, I think for the thought process, for everyone able to kind of look into and comment and add on that. So I think kind of add, for example, here in the RDO, a lot mechanical, electrical, IO information related here that will be needed. I think there's definitely a lot of overlapping information that has been covered quite a bit on the dial and the IO area. And then on the substrate, we have different silicon, organic, interposer, right? And then the TS we kind of put in here because they're kind of relevant. So just kind of high level, I think the material, different thickness, CT might be required and things like that. Right? For interposer, there's an RDO requirement and things like that. So they're kind of be overlapping everything. I just kind of put in there what I can thought from my kind of experience. So I think I just want to put in something so that to start with, and then can get everyone feedback and help and add on top of that, especially I think more expertise background or experienced people can help to cover more of this area. And then same thing for the 3D, mainly a lot there's a TSV, different layers, different stack up, there's a core walls and things like that, right? So hybrid bonding and things like that. So I think I just put in there on the high level. Same thing on the packaging side. I think there's advanced packaging, and then there's all other general standard packaging like BGA, CSP, LGA. So advanced packaging, you have the fan out or SIP, WL, CSP, 2.5D, 3D, those kind of advanced packaging. And then thermal, I think that's kind of standard. We quite a bit probably. I think in raw material that we have today, but I just kind of put in here. I think I see any additional that we think should be fit into here. In general, CTE thermal cycling, flux and things like that, and then all the cooling solution, right? And then the last thing, not the least, is the testing. We have we talked about last time the wafer saw, prop card. And then I kind of added the test requirements, right? So and then in general, the wafer saw, I think so there's kind of different prop test sizes, testing point, and then the prop card, there's prop pitch and things like that, signal integrities that generally I think it will be tested over there. And then in general test requirement, you have different temperature, sort parameters, and these kind of continuous function test patterns. So that's kind of where I have. I think today, I think I'm expanding like from what we have previously. So yeah, I'm going to pause a bit here. I think like for the feedback and input here. I think like and see like what you think that we have so far and what has been, I think, like put at the starting point here, and then also what you think. So in general, what we should be covering today. Tony, do you have anything else that you want to input from your end? So.
Well, yeah, there's a lot of stuff here, James, and I think the priority really is to start defining the format for assembly design rules. So I think we really need to focus on that. Now, Intel has a proposal for that, and I thought they were going to schedule a meeting to review what they had proposed. Did that happen while I was traveling, or has that not yet happened?
Yeah, I think Intel has proposed that. I think I have shared that, like Chris has shared that. I think like the die to dice, right? In general, die to die spec. So I think that's a lot covered in the. I think it's very focused on the die. No.
That's the die definition. Yeah, that's the die definition. That's very different. There's three components to what Intel's provided. They have the die component, and then there's the 3D stack. And right now they're really are not proposing a 3D stack format. At the current time, they're planning on supporting 3D blocks because they think that meets their needs. I'm not sure we've made that decision yet, but right now that's a placeholder as a potential candidate for the 3D stack. And with the die definition, there's actually one piece of it that is defining the probe pads. We haven't started that yet. But then the assembly design rules is kind of really the separate thing, and that's what the purpose of this working group is to work on the assembly design rules. I think we're far enough along with the die definition. You know, we've essentially, I think we've conceptually agreed. I don't know, we haven't officially agreed, but conceptually, the discussion we had is, you know, they had proposed a YAML implementation of that, and we said, well, we already have kind of a definition in the JEP 30, so why don't we do that? So what we did is, and then the initial feedback was, well, it can't handle the capacity, it doesn't meet our requirements, and so I said, if we can get JEP 30 to meet your requirements, are you okay with that? And we ran through the test cases, we modified the format, and I think we're there. So I think we need to have that discussion. Are we good with the die format at this point? You know, excluding the additional work that needs to be done on the wafer sort.
Right. So this is Michael here. I can give you an update on that. So okay. There is two aspects to putting this through to the JEDIC from a balloting perspective. There's the physical section which goes into the JEP 30-P. That was we described the whole process to the entire committee there last Thursday. They gave us some feedback in terms of they'd like to see some additional images to represent the structure that we created in the XML. But other than that, they have all agreed to proceed and let the task group submit that to the ballot process as soon as we have the images drawn for an example and put into the PDF file. On the
well, yeah, Michael, you're jumping ahead a little bit. You're talking about the adoption by JEDEC. So I was just saying, internally, this working group, are we comfortable that we're going to proceed forward with the JEP 30 being the .die and test information? So it sounds like so far so good with JEDEC, but you know, we need to get a little bit of closure and make sure that we're all going to move forward with this before we push JEDEC too hard. But I think that's the direction we're going.
So Tony, I have a few questions. In this die format description.
Yeah.
What additional information does Intel have that we haven't covered in CDXML already?
Well, the test cases that they've given, I think we've met those requirements. I just want to get the feedback from Intel that says, yes, you've met our requirements. So they haven't, Chris hasn't been on. So I believe that we've met the requirements. So we just need to formalize that. And then the working group here, we need to make sure that, Cadence is bought in, and anybody else who's, got a stake in this format.
Got it.
Right. Now, we really need to get working on these assembly design rules. I think, that's something that, Intel has a proposal. We haven't really seen it yet. I know they've shared it with some of the EDA vendors, but they haven't shared it with CDX yet.
Yeah.
And we need to get them on the agenda. And I was hoping that was going to happen today, but it sounds like it's not.
Okay, so let me give you a little bit of background on this. And actually, you sent me to SI2, right? On some of this topic. So I had a conversation with them yesterday, and I was just really trying to understand, what is the push behind it. And seems like Intel is pushing SI2. And Intel
They're pushing SI2?
Yeah, that's kind of what I figured out. I'm going to go and try to get to the bottom of it.
Do you know who's pushing? Because it's probably Vivek who's been pushing it. And Vivek, Satish is not pushing SI2. He's already told them, no, we're not doing that. I've told SI2, no, we're not doing that. We're not using the MDX format. MDX is for assembly design rules. It's not the die format.
Okay, so their point is assembly design rules, right?
Right, that's the MDX format. Now, Satish has told me that they are not supporting that. They've told that with SIT. I've had several meetings with SIT. I've had a meeting with the guy who's running the working group in SI2. I said, no, we're moving forward. So I've had several discussions, and this keeps coming up. I have a feeling it may be Vivek that's pushing this, because he is working closely with the Synopsys folks.
Yeah,
but we're not supporting this. And
so, Tony, I'm going to give them the same message that we have. Okay, that is a given. But my question to them was, guys, help me understand what is the complexity of a assembly rule set. ASE is on the call. There are 5 things that they will say, hey, die to die spacing, die to edge spacing, maybe a few other things.
Right.
And my point is, hey, look, we have this design kit effort, which is much larger than just the assembly portion, which has materials, which has testability, which has the CDK and all of that. And as part of it, we will cover a format which is going to be useful for assemblers, and it will be useful for designers to primarily deal with the spacing constraints, right?
Right. Yes.
And
agreed.
And I want to understand in this group that what is the most complex rule set that we can think of for assembly in the future. And even if we take into account 2.5D and 3.5D and 4.5D, all of that, and we say, okay, we think if we have to do a construction vertically in 3 dimensions, this format will do the job. And if we have to do side by side, this format will also do the job, right? So it would be worthwhile for us to maybe look at one of the test cases of a complicated assembly and see what the assembly constraints, how did the designers handle that, and We just take one of our formats and say, hey, we think that these things have to be defined by assemblers. That would be future proof, and all the designers will understand how to make use of it.
Right. So Jawad, I agree 100% with everything you said. But Intel already has kind of a summary of rules, and we want to look at those as a starting point.
Yes.
They are, they do this, they do assembly, and they assemble some of the most complex things, but we're not developing an Intel standard. If it meets everyone's needs, fine, but they're providing inputs and they're providing a starting point, but we need to get ASC, we need OSATs. Ideally, I'd like to get a substrate vendor, and I'd like to get another fab, and those are the guys who are really driving the rules, and they need inputs and to make sure that they're comfortable representing their needs. I mean, the EDA guys need to support it, so we need to make sure the formats are usable and can be consumed and managed from a tool perspective. So this is really a collective group, and we need end users also, right? So Intel has some test cases. They haven't delivered those, to my knowledge, to CDX yet. They do have test cases that they will provide. We're going to need test cases from ASC, and I don't know if there's anybody on ASC in the call.
We have Roger here.
Roger?
Yeah, Roger, can you maybe help with that?
Yeah, do you have test cases that you can provide for assembly design rules? I think, a fan out and an interposer, some test cases would be great if we can get those. Intel has some test cases. I'm trying to get some from Samsung.
I think we just only can define a general rule.
We don't real rules. This is open source, so we need a contrived open source test case that basically captures what we believe are the salient rules. Now, there may be some very specialized rules unique to your process, and if you're not comfortable sharing those, that's fine. I think we should make sure that the format can handle that, so you can describe those rules, but and we can do that, with you or Intel, whoever, maybe in a separate, whoever's actually developing on the format, if they're not comfortable, because we've got multiple competing bodies here, so we need to be very sensitive to those test cases, and whatever you provide needs to be generic enough. But again, we want to make sure the format is robust enough where it can capture everything, and maybe we just have private for when those proprietary rules that the vendors are not sharing, we could just provide them. We're going to have some level of trust. I don't know who's going to do the implementation, if it's James or whoever, to make sure that we're meeting all the needs of the contributing parties.
I think I need to discuss this with the team internally. And the first one is I think I'm not sure should we depend on the different product to separate the format. For example, for the FPGA, maybe you a multi-chip module FPGA, maybe you have the die to die space or the die to HBM space, die to substrate space, right?
Well, right now we're talking about assembly rules, right? So these are the interconnect rules. So and there's going to be several categories, right? We got interposer, we've got organic interposer, fan out, whatever you want to call it, and you have a traditional substrate, right? So
Yeah,
I think probably the easiest one to start with is the silicon interposer, because they're all relatively straightforward. And then we need to figure out. I think fan out would be good, and BGA. Those are the three main ones that we need to cover, and we want to make sure we have a common format that can describe all of those.
Yeah, I just mentioned based on the different product, we will have the general design rule, including maybe the bump dimension and the related distance, and maybe have the capacitor, a size, and the heat sink, and the related distance is very important to define rule.
So that is a little bit different, but we do want to encompass that. So the first thing is just your basic assembly rules, right? So this is the rules so you can build the interconnect, right? Place the vias, the through silicon vias, the bumps, the micro bumps, whatever, and route those. Now there are additional, and I believe the Synopsys format does all support that. But one of the issues that Intel had, and we have as well, and I imagine Cadence does, I talked to Mike, he has the same concerns. There's other rules that you have to worry about. There's other rules that you want to define for placing things like capacitors, or you may need a rule on how far the die edge needs to be from the package cavity. So
sure.
All those kind of things. We want to be able to make sure the format has that, and we need to have a structure to kind of have a nice make sure the schema can organize these in a manner where it's easier to enter the information rather than just having everything jumbled into one big file. That's what we want to kind of sort out, really, is the format to do that. I think there is, at least in talking to Michael Durkin, there would be a preference, but not necessarily a requirement to do it in XML. There a lot of these rules are in YAML, but we should look at XML and YAML. I think those are the two that we're considering. There's pros and cons of each, but the die is already a standard, so we hopefully agree to move forward with the JEP 30 satisfying the die definition. But the assembly rules, I think the format, we're not quite ready to have that discussion, but now it's just, what are the types of rules we need to capture? That's really what we should do. And let's just agree, what should we start with? Does it make sense to start with a silicon interposer? I think that's probably the easiest one. Those rules are pretty straightforward.
Yeah, so Tony, I think based on what you said, I think some of them are kind of also here. I think you want to highlight priority, right? I think for example in here substrate, you want to focus on silicon and then interposer, right? I think then.
Yeah, I can't figure out how to get back on the meeting. They loaded Windows 11. I don't even see the app running. Oh, here it is. I found it. Okay. Yeah.
So Tony and James, I want to add an input here. Basically going back to what Jawad was saying, we need to aim to capture all the technology that we foresee coming out, right? So one example I could think of to kind of just shape my thought was the DECA technology, for example, the adaptive patterning. That's irrespective of the interposer or the organic substrate. It just requires a certain kind of a class of design rules that should be part of this ADK. So
I did invite someone from DECA.
Yeah.
Are they still on?
They're not. They have not been calling in, but
no, they haven't. But are they still on? Yeah. Are they still on the invite, David?
I see them on the list.
Okay. Okay.
Yeah. So it's a dimension here in this table. Basically, it's another row of itself, right? We call it adaptive patterning. Yeah.
Yeah, which is used for organic. So again, there's organic is I think is it's going to be a more complicated problem. I think most silicon interposers are pretty straightforward. So I think we need to start that. We do want to have the list, but you know, we need to start moving. So we've been spending most of our time on the die format. You know, there's still work that needs to be done, but I really want to get started, you know, in our next meeting to actually let's start, you know, getting. I think the first thing is let's see what Intel has. That's a starting point.
Right.
You know, we can still reach out to Synopsys and say, hey, if you have something, if you're willing to share it with us, we'll look at it. So I can have that conversation. I've asked them no less than 10 times, and they've never agreed to share it with us or Cadence. So until they do that, and that's the main reason we wouldn't even consider it, because they were not willing to share it. So if they've changed their position, then I would be open to looking at it. You know, maybe it's a hybrid between, you know, what Intel has and what they did. But you know, let's we really need to get this moving.
Right. So I hear like silicon, and then like interposer, right? That's the area we like to start with, right?
Where you look, there's a lot of stuff in your box here. So
yeah, I highlight this one. So under
yeah.
the substrate area, so we have the silicon.
So
and
where is the rules? These are the components. So where does it say silicon interposer and organic interposer?
Here, I mean, I'm just kind of put high comment. I think put in some parameters or relevant. I think needed for those many of the rules. So when specify, I think like specific rules, but kind of like in general, highlight. I think like the parameters that will be needed. I think like for many of the like some of the description of the rule as well. I mean, like for example, I think like the thickness, right? So I think like materials, and then like the routing, and pitch and information or others, right? So
there's a lot of stuff here that we really need to start honing in on. What do we need specifically to define the rules?
I have some questions there to ask you, James. So under the mechanical section, you have die size, dimension, active die area. These are things that we had defined in the die array section of the part model.
Right.
Why when you're putting this file that you're showing is about assembly design kits. So I'm assuming that you'd want to have the die size and the active die area to have the same definition between the two type of files.
Yes.
Well,
mentioned earlier.
Why is die size even in here?
It's an RDL routing. Like you need that to know when you put your RDL layer in to know where.
No, that's when you're doing the routing. But when you're defining the routing rules, you're worried about width, spacing.
You have to worry about
density. Those are the kind of rules that we're talking about.
No, you need to know where are the dies, right? Where are the placement and position. Like when you do the route die, then you need to know, so that like when you do the spacing rule and things like that, then you can calculate that way, right?
But aren't you reading in from the other file, the file that contains the definition?
Yes, I think Michael. Yeah, I think I got interrupted. I trying to answer yours. I think Mitch I mentioned earlier, like some of this information that already there. So just put in there kind of like in general to cover from completeness purposes, right? Yes, some of this already here, we already covered. You're probably not going to repeat this thing. You only kind of look into many other things like theoretical, right? They are in the CDXML and Jet chapter already. I just kind of put in here completeness so that make sure that like we cover many things that what we needed for here, and which already covered in our section, and make sure we don't miss anything. So I just kind of lay out in here. right? Doesn't mean that we have to include any new things here, but I just want to resale for completeness. Many of these things, yeah, for example, I think all these things, most of things actually like already cover other area. But I think there are only some specific area like Tony mentioned. I think there will be kind of like the thickness and width of the RDL layers, right? I think what type of RDLs. I think I kind of missing here, like type of RDLs, like
But my question here is, are you going to have two different sources for the same information? You don't want to do that.
No, we don't.
So if the die size and dimensions and the active area, active die area, if all that's defined in another file, then what you should be doing here is not including it inside the assembly design kit, but maybe reference it. You can reference it, but don't include it.
Michael, yeah, I want to stop you here. I think I just kind of like for this here again for information purposes only. I think I understand what you're saying. But I think for information purposes, I think like many of things already cover other part area, right? So I already say that already. So that's kind of repeating what your question are.
But
okay.
I do believe that we need to capture information related to constraints on what kind of die can be placed in a package. So there could be minimum die size or maximum die size or dimension or the thickness constraints imposed by the substrate.
So you
that
come again
information.
with the question?
Yeah, that's
not question.
Yeah.
I'm saying that the information related to what kind of die can be placed needs to be part of this ADK, right? The thickness of the die, maximum thickness or minimum thickness for that.
Yeah, and all of the criteria that you define for those rules as the min and max limitations that you apply, you need to make sure that every one of those labels are also defined in the die array file, so that you're not doing any transformations of terminology. So if you choose, for example, minimum die size, minimum die width, die length, for example, right? Make sure you use the same terminologies for defining the die width and length in the other file, so that it becomes very simple to say this is what I the metric or the terminology that I'm using.
So another way to think about this, let's just say that, you know, we're going to create a set of rules in order to connect die on an interposer, right? So there is no die yet. So if we have these rules, you know, there's a min max, you know, micro bump. There's you know, TSV spacing rules, and there's going to be density rules and corner rules. And so if a multiple die vendors want to create dies that are going to be connected on a interposer, you know, we need a set of rules that all the chiplet vendors need to make sure they're meeting those rules so that they can be assembled, right? So they're going to use these assembly design rules to make sure their chiplets are meeting those rules. And if they don't meet those rules, then they're not going to be able to integrate it on that interposer. Now, it's easy if you're a single vendor like TSMC and all the chips are coming from TSMC, and you know, they're building the interposer, so they're mandating what that is if you want to integrate it in with TSMC. And you know, everyone supports HBM, so that's a given. But there's other rules that need to be dealt with, so they're manufacturable. So that's this is the format to describe those rules, and ultimately there would be a rule checking, a PDK file that's going to check to make sure that your die is meeting those rules. And then when you're actually building your interposer, you're using those rules to build the interposer, and you need a rule deck to check those as well.
Right. I think yeah, there's something I think Tony, what you just said also. I think we kind of maybe also like they're already been assembly. I think again, so like in this kind of assembly here, I think like we talk about 3D stacking, so they're kind of TSV and some of this kind of alignment, tolerance, and like offsets right between tiles and things like that when they set up in orders, right?
Yeah.
So
So the die file doesn't have rules, right? The die file is just describing the die, right? But that die needs to be built to meet it, to make sure that it can be assembled.
Right. I think some of this rule you're talking about, yeah, like the ratio of the COW, right? COS and these kind of things, right? The underfield also, right? I think this kind of rules, like including hybrid bonding and things like that.
Well, there is a whole other set of rules that started getting, you know, involved in actually putting the package, and I try to differentiate that as package assembly rules versus just straight ADRs, assembly design rules. So you're probably going to be running a caliber type sign off check for those assembly design rules on the interposer and the die, right? But when you're building a package, you're probably going to be using a package DRC checker. So those are a different class of rules. So we want to cover all those rules, but it's in a different context.
Okay, so I mean, like that should be
so just to keep us kind of focused in making sure that everyone is in sync on what we're trying to do here. I think the silicon interposer is a very simple model. It's been around for many years, and let's start with that. Fan out has a lot more different flavors and a lot more, you know, sophisticated rules. We need to do that, but let's start with the easy one first, and then I think, you know, the other rules where you're going to be used to do the mechanical package, then, you know, that would be, I would say, would be the third priority.
So are you talking about, I think, like trying to separate this like assembly design rule from the packaging design rules? Have a separate files on that, or what are you thinking, Tony?
Well, they're probably going to be separate decks, or at least separate sections of the deck. I mean, that's what we're trying to figure out, how to organize all these different types of rules.
So, Tony, I have a few comments. All of these design kits, they pertain to a specific assembly line or a manufacturing line. Even when you go to TSMC, if you're working with their front-end factory, the PDK is different. Working with their back-end bumping factory, PDK is different. We end up plumbing the two together. So if you look at the package design in general, there are interconnect suppliers, which are making interposers or substrates. They tend to give you their design rules in the which basically is specific for their component, right? So in my mind, that is somewhat of a different problem statement than assembly, because that's basically fab design rules of various type of components. And then there is an assembler, which, you know, usually this whole supply chain is hidden behind that assembler. So we think that this is just the assembly portion. But typically, if you go to a assembler in the valley, all what they're going to do is pick and place, ball attach, maybe do some testing with it, maybe do molding on top, right? So when we say assembly design kit in particular, from Intel's point of view, what do they want included in it? Because they already have really good PDKs for their silicon interposer.
Yeah. But they have a lot of additional things that are all the other stuff you talked about. So we need a format, and like I said, let's see what they have. You know, if Synopsys is willing to share what they have, we can look at that. I mean, TSMC doesn't have those other things because they don't get into the package assembly, but they certainly have the assembly design, the routing design rules and the TSV, you know, the stuff that's required for manufacturing the interposers and the
Sure.
and the die. So, and they have a format for that. What we're having is, you know, it's gonna, by definition, it's got to be very similar because we're describing the same types of objects.
Sure. So, but Tony, one thing where we can help everybody is by defining, you know, which part of this design kit that we are talking about refers to which part of manufacturing. If we can connect those two things together, even in a Excel sheet table, I think that will be a big help for everybody in resolving a lot of confusion.
Yeah, let me see that slide deck I have in the 3DKs. Where's it?
Why are you finding that, Tony? I think I just want to elaborate more. I think from you and Jawa's discussion, I think and it seems like priority if we're going to or want to start from silicon interposer, the way we structure as a component here, maybe I think there's a different, maybe we can start with a different verticals, separate sheet, just focus on silicon interposer and start from the rules there. And then we can come back and the components and matching and backfill in this component section.
Let me share what I have and see if this is what you're looking for.
Stop sharing.
Let me know if you can see this.
Yes.
Okay, so this is what I call package assembly design kits, or PADK, right? So package planning, this is the chiplet physical model. This is the JEP30 die model. So we've got that. We have the stack up information. That's something right now we've got the 3D blocks stack up as a proxy for this. And then, so this is kind of used for package planning. For here, these are the assembly design rules. So these are the rules for placing your connectivity components, you know, your bumps, micro bumps, how far they need to be away from corners, what the density is of those, and these are all min-max. When you transition your arrays, there's rules for that. So that's what's in here, you know, your width, your spacing, all that kind of information. And then these were kind of what I called the package component placement rules, where, you know, you would have, you know, maybe fill type rules and other stuff in there. And then this wafer sort, you know, I had that as a separate, but this really is kind of a subset of this chiplet physical model.
Okay, this helps a lot, Tony. So basically, in your mind, a package assembly design kit is much bigger than an assembly design kit, because it includes CDK, it includes PDKs of different components. It definitely includes ADK, which is component placement rules and ball placement rules, right? And potentially even test, right? So
so it's a superset of what's in 3D blocks. It's a superset of an ADR, right? An ADR is a PDF document for assembly design rules. So this is, I think, this is the whole kit, right? And the idea is there's, you know, there's multiple components of this. And
right. So we have already addressed the chiplet physical models, right?
Yes.
So what we have not addressed are
we haven't started this yet. So this is really a part of that. I'm just listing this, not structurally, but the things that we need to cover, right? So I'm grouping them by functionality.
Okay.
package planning, package design, and test support.
Yeah. So, you mentioned wafer test support. So wafer test support belongs to either the chiplet or a silicon interposer, right?
Yes.
It's not exactly the assembly problem. It just so happens that OSATs do provide testing services as well, right?
Right. This is on the die. So this is how are you you're doing that, and when you get into like stack die, it gets a lot more complicated,
Sure.
right? Because I've seen some cases where they don't actually put physical probe panning on the die, right? That's actually done by the OSAT or the assembler, where they'll actually do a fan out to test it, and then when they're done testing, they'll get rid of that. So that's because you can't put probe pads on.
Sure.
They're too fine, right? You're talking micron pitch. You're not going to sacrifice for every probe pad you need, 100 nano bumps or whatever they're called, the hybrid bond. Yeah, the hybrid bond. So this is it's pretty straightforward for an interposer or a flip chip die. When you get into micro bumps, that's where people are putting in they're called sacrificial pads, where you sacrifice a few of those micro bumps and just drop in a pad, which is not used in packaging. It's only used in test. So that's why those micro bumps, you're actually are losing those access to those micro bumps and it's primarily for power and ground, right?
So, Tony, in this meeting that we have alternate weeks, I think we should focus on assembly design rule and package component rules.
Yeah, this is the one I'd like to start with, because I think these are going to be vary from vendor to vendor and what you're doing. So these are going to be, we need to make sure we have the right structure and the format to describe those rules. But let's start with this for silicon interposer type designs. I think that would be a good place to start. And then I would do fan out, build on that and do fan out. And those are the two popular ones. And then maybe we can start looking at these and even hybrid bond. We need to start thinking about that as well.
Okay, so we'll wait for hearing from Intel. But we can ourselves start making progress on these. So you let us know.
Yes.
It's better if Intel comes in, right?
Yeah.
Yeah, because they already have something, right? They have their own internal format, which is very Intel unique, and they're not going to use that, but they proposed a format that describes a lot of these roles. Let's look at it. They've offered us to use it. Let's look at it and build on that. And again, we want to make sure that it's not Intel only, right? So we need to make sure everyone else in the group is represented to make sure the types of rules that they have can be addressed in this format. And again, we really need to get test cases to make sure this works. And maybe we start working with different fabs or OSATs to even privately say, here's the format, and just give that to them and let them try to capture the rules and see if they can capture it in the format. And if they say no, we need this and that, that's how maybe we can handle those one-off rules that without having those as part of the the open source test cases that we're including in CDX.
Yeah, and we are lucky to have ASC here, so they can give us some feedback, right?
Yeah. And I think Amcor is just announced they're building a big fab, and we can talk to them as well. But ASC is part of the team, so let's start with them. But again, we want to make sure that we're not driving this from one company. We're trying to come up with a standard format that's going to be applicable as broad as we can make it.
Yeah, makes sense. So I think I continue. I think now since I have a better idea, I think thanks. I think through Tony and Java for information. So I think I will probably start with as suggested from Silicon proposal. So
yeah, I sent this to Jawad and David. So this is a variant of what I presented at OCP. So this is how I'm viewing this, and if we all agree, let's start working on this piece. If I think Intel may have used a different terminology, so we don't have to use their terminology. Let's make sure we're all on the same page, so we're all going in the same direction.
Yeah. Who from Intel will be? Do you think that you were able to get the person present in the next meeting?
Well, yeah, they offered, and I'm not sure why it didn't happen. Yeah, but I'll coordinate it with Satish. So we should invite him to the next meeting. So I don't think we're going to meet in 2 weeks.
Yeah. You mean,
right.
Okay, Satish and Chris, right? So okay, we'll remind them.
Yeah, it's probably going to be Chris. So I would say, James, why don't you or David, have it come from CDX rather than coming from me.
So yeah, I can go.
Just say we'd like you to present, your proposal for the assembly design rules at the next 3DK meeting, which whenever that is. I don't know if we've scheduled those yet, have we, David?
Yeah, in 2 weeks from now.
2 weeks. 2 weeks is the 21st. 20 after that, definitely not having one. 21st, I don't know. We have to decide if we're going to have on the 21st meeting or not.
Well, why don't we decide now? We've got everyone on there, everyone here.
I think we should continue. I think we
21st is probably going to be a problem for me, but let me look at my calendar.
Because you're traveling?
Then the first week of January is the next one.
Well, just because I can't make it doesn't mean we don't have it. So the 21st is all right. I mean, who cannot make it on the 21st? Who's on this call? Is there anybody who cannot make it?
Siren, we assume that's a yes for you.
So let's schedule it for the 21st. But why don't we just see if Intel's available first?
Okay. Yeah.
So
Well,
if they can do it, let's do it, and I will attend.
Okay. I will send and CC you then, and then and David and Joe, and then hopefully they will be available.
Yeah, but ping them first, make sure they're available, and I think that's the next step. So Satish did say, he's ready to share those with CDX, and I've been traveling for the last 2 months.
You have been kind of like missing the action for many times, Tony. You have to make it up though.
I got back last night, and I'll be gone in Japan all next week, and I'm leaving again Sunday for Japan. So. But that's it for the end of the year for me, traveling.
Yeah, a lot of traveling.
Yeah, the last 2 MDK calls I took from my car, one in San Diego, one was in Austin.
Oh, well, hopefully you can make it from your car again in the next one.
No, next one I'm not traveling, so I'll be at home for that.
Okay, that's good.
My home office, yeah. Okay, so does this help? We all kind of, Rudy, any thoughts on this? Are you comfortable with this?
I think Rudy just dropped. I think he was.
Okay.
Yeah.
Yeah, and okay. But
Okay.
yeah, so let's, yeah, that would be great if we could at least have that, and then, you know, in January we actually start, you know, defining the rules and getting them moving forward.
Sounds
But
good.
I think, yeah, they've got a, you know, they've got a lot of thought. They've already got, you know, slide decks to do it. So I think that's a good place to start.
Yeah, I think hopefully there's something similar into the die spec also. I think similar to that. I think the oral coverage. I think that would be good to start something
Right.
that.
So the EDA guys do have access to 3D blocks, and I believe Intel has access, but I don't know if they're going to let that accessible to CDX, and I'm not sure we want to even bring that up right now, because I know a lot of several fabs that I've spoke to will not support 3D blocks just because they view them as a competitor.
Right. Okay. So we have to do something about that one, right? So after this, the spec from Intel, maybe that's something we can look into there on the 3D.
Right.
Stacking.
Okay. Yeah. So let's get that in. Yeah. Let's try to get that in by tomorrow. So to know whether or not that's going to happen.
Okay. We'll do that. That's good.
I would. Yeah.
I'll email to Sachin.
I will email that to Satish then and CC you.
And Chris.
And Chris, yes.
Yeah.
Okay.
And if they can do it,
so
if they can do it,
you're
then
gonna
we'll
send
send
emails?
it out to everybody.
Sorry? Yeah, I'm going to email. Yeah, I will CC you, Tony and Jawad.
Great. All right. I got to go. Thanks.
Okay. Yeah. Thanks, everyone.
All right. Bye.
Oh, yeah. Bye.